According to the National Electrical Code, NEC, low-voltage communication cables such as IW can be attached to the following. Firstly, building structural members, for example, joists and beams. Secondly, dedicated support wires or cables. Thirdly, electrical raceways or conduits. And fourthly, suspended ceiling supports if they are listed for such use. Now, whether or not you can attach to alarm support wires depends on whether they meet the above criteria. Firstly, are they listed for such use? Check with the manufacturer or the electrician who installed them. Secondly, are they dedicated for supporting communication cables? If they are also supporting alarm cables, they may not be suitable. Thirdly, are they securely attached to building structural members? I would recommend contacting the electrician and asking them if the alarm support wires are listed and suitable for supporting communication cables. If allowed, use cable ties or Velcro straps to attach the IW cables to the support wires. If not allowed, install dedicated support wires or use another approved attachment method, such as hanging the cables from the ceiling joists or beams. Additional considerations include ensuring that the cables are not subjected to excessive heat or moisture. Avoid attaching the cables directly to the ceiling tiles, as they may become damaged. Label the support wires or cables clearly to avoid confusion with electrical wires. For further clarification on acceptable attachment points, let's delve into each category. Firstly, building structural members offer a robust and reliable option. These include joists, which are horizontal structural members used to support a ceiling or floor, and beams, which are larger horizontal members that carry heavier loads. Attaching low-voltage cables to these structural elements ensures that the cables are securely supported and are less likely to be damaged or dislodged. When attaching to building structural members, it is important to use appropriate fasteners and techniques that do not compromise the structural integrity of the building. Secondly, dedicated support wires or cables are specifically designed for the purpose of supporting communication cables. These support systems are typically installed in a grid pattern above the suspended ceiling and provide a network of secure attachment points. Dedicated support wires or cables are often preferred because they allow for flexible cable routing and can accommodate changes or additions to the cabling infrastructure. When using dedicated support wires or cables, it is essential to ensure that they are properly tensioned and that the cables are securely fastened to them. Thirdly, electrical raceways or conduits offer another option for attaching low-voltage cables. Raceways are enclosed channels that are designed to protect and route electrical wiring. They can be made of metal or non-metallic materials and are available in a variety of sizes and configurations. Conduits are similar to raceways but are typically made of rigid metal or plastic. Attaching low-voltage cables to electrical raceways or conduits can provide a high level of protection and can help to keep the cables organized and out of the way. However, it is important to ensure that the raceways or conduits are properly sized and that the cables are securely fastened to them. Furthermore, care must be taken to avoid interference between the low-voltage cables and the electrical wiring. Fourthly, suspended ceiling supports may be used as attachment points if they are specifically listed for such use. Suspended ceilings are typically supported by a grid of metal framing that is suspended from the building structure above. Some manufacturers offer ceiling support systems that are designed to accommodate the attachment of communication cables. These systems typically include features such as cable trays, J-hooks, or other attachment devices that allow the cables to be securely fastened to the ceiling supports. When using suspended ceiling supports as attachment points, it is crucial to verify that they are listed for such use and that they can support the weight of the cables without compromising the integrity of the ceiling system. Now let's consider the specific situation involving alarm support wires. It is important to exercise caution when considering attaching low-voltage cables to alarm support wires because these wires may not be suitable for supporting additional cabling. Firstly, it is essential to determine whether the alarm support wires are listed for such use. This information can typically be obtained from the manufacturer of the support wires or from the electrician who installed them. If the support wires are not listed for supporting communication cables, then it is not advisable to attach the low-voltage cables to them. Secondly, it is important to consider whether the alarm support wires are dedicated for supporting communication cables. If the support wires are already supporting alarm cables, then they may not have the capacity to support additional cables. Overloading the support wires could compromise their integrity and could potentially lead to a failure of the alarm system. Thirdly, it is crucial to ensure that the alarm support wires are securely attached to building structural members. If the support wires are not properly anchored, then they may not be able to support the weight of the cables. It is also important to verify that the support wires are in good condition and are not corroded or damaged. Now let's discuss the recommended course of action in this situation. The first step is to contact the electrician who installed the alarm support wires. The electrician will be able to provide information about the type of support wires that were used and whether they are listed for supporting communication cables. The electrician can also assess the condition of the support wires and determine whether they are suitable for supporting additional cables. If the electrician confirms that the alarm support wires are suitable for supporting communication cables, then you can proceed with attaching the low voltage cables to them. However, it is important to use appropriate attachment methods and to avoid overloading the support wires. Cable ties or Velcro straps can be used to securely fasten the cables to the support wires. If the electrician advises against attaching the low voltage cables to the alarm support wires, then you will need to install dedicated support wires or use another approved attachment method. Dedicated support wires can be installed using a variety of techniques, such as suspending them from the ceiling joists or beams. Another option is to use J-hooks or other attachment devices that can be fastened to the ceiling structure. When installing dedicated support wires, it is important to ensure that they are properly tensioned and that the cables are securely fastened to them. Let's now address some additional considerations that should be taken into account when installing low voltage cables above suspended ceilings. Firstly, it is important to ensure that the cables are not subjected to excessive heat or moisture. High temperatures can degrade the insulation of the cables and can potentially lead to a short circuit or fire. Moisture can also damage the cables and can cause corrosion. Therefore, it is essential to route the cables away from heat sources, such as light fixtures or heating ducts, and to protect them from moisture. Secondly, it is advisable to avoid attaching the cables directly to the ceiling tiles. Ceiling tiles are typically made of a fragile material and can be easily damaged if cables are attached to them. Additionally, the weight of the cables can cause the ceiling tiles to sag or even fall out of the ceiling grate. Therefore, it is best to use dedicated support wires or other attachment methods that do not rely on the ceiling tiles for support. Thirdly, it is important to label the support wires or cables clearly to avoid confusion with electrical wires. Electrical wires carry potentially dangerous voltages and should be handled with caution. Clearly labeling the support wires or cables can help to prevent accidental contact with electrical wires and can ensure that workers can safely access the cabling infrastructure. Labels should be durable and easy to read, and they should be attached to the support wires or cables in a conspicuous location. In summary, attaching low voltage cables above suspended ceilings requires careful planning and attention to detail. It is important to comply with the National Electrical Code (NEC) and to use appropriate attachment methods. When in doubt, it is always best to consult with a qualified electrician or other professional to ensure that the installation is safe and code compliant. By following these guidelines, you can ensure that your low voltage cabling system is properly supported and will provide reliable performance for years to come. The NEC provides detailed guidelines for the proper installation of communication cables, including low voltage wiring, to ensure safety and prevent electrical hazards. These guidelines cover various aspects of cable installation such as cable types, wiring methods, support requirements, and separation from power conductors. Understanding and adhering to these requirements is essential for ensuring a safe and compliant installation. One of the key aspects of NEC compliance is the proper selection of cable types for specific applications. Low voltage communication cables, such as those used for data, voice, and video, are typically classified as either plenum rated or non-plenum rated. Plenum rated cables are designed to be installed in plenum spaces, which are air handling spaces above suspended ceilings or below raised floors. These cables are made with special materials that are fire resistant and produce low smoke and toxic fumes in the event of a fire. Non-plenum rated cables are not suitable for installation in plenum spaces and should only be used in other areas. Another important aspect of NEC compliance is the proper wiring methods for communication cables. The NEC specifies the types of wiring methods that are permitted for different applications. For example, communication cables can be installed in conduits, cable trays, or raceways, or they can be supported by cable ties or other approved methods. The wiring method must be appropriate for the environment and must provide adequate protection for the cables. The NEC also specifies requirements for the support of communication cables. Cables must be supported at regular intervals to prevent them from sagging or becoming damaged. The support method must be appropriate for the type of cable and the environment. For example, cables can be supported by cable ties, J-hooks, or other approved methods. In addition to these general requirements, the NEC also includes specific requirements for the separation of communication cables from power conductors. Power conductors carry high voltages and can pose a shock hazard. Therefore, it is important to maintain a safe distance between communication cables and power conductors. The NEC specifies the minimum separation distances that must be maintained. By adhering to the NEC guidelines for communication cable installation, you can ensure a safe and compliant installation. This will help to protect people and property from electrical hazards and will ensure that your communication system operates reliably. It is also important to note that local codes and regulations may also apply to communication cable installations. These codes and regulations may be more stringent than the NEC requirements. Therefore, it is essential to check with your local authorities to ensure that your installation complies with all applicable codes and regulations. In addition to the NEC and local codes, there are also industry standards and best practices that can help to ensure a successful communication cable installation. These standards and best practices cover topics such as cable selection, installation techniques, and testing and certification. By following these standards and best practices, you can improve the performance and reliability of your communication system. One important industry standard is the Telecommunications Industry Association (TIA) standard for structured cabling systems. This standard provides guidelines for the design, installation, and testing of structured cabling systems, which are used to support a variety of communication applications. The TIA standard covers topics such as cable types, wiring methods, and performance requirements. Another important aspect of communication cable installation is proper grounding and bonding. Grounding and bonding are essential for protecting communication equipment from electrical surges and noise. The NEC specifies requirements for grounding and bonding of communication systems. It is important to follow these requirements to ensure that your communication equipment is properly protected. In addition to these technical considerations, there are also safety considerations that must be taken into account when installing communication cables. Communication cable installations can involve working at heights, working with electrical equipment, and working in confined spaces. It is important to follow proper safety procedures to prevent accidents and injuries. Before starting any communication cable installation, it is important to conduct a thorough site survey. The site survey should identify any potential hazards, such as electrical wires, plumbing, or structural obstacles. The site survey should also determine the best route for the cables and the appropriate support methods. Once the site survey is complete, you can begin the cable installation. It is important to use the proper tools and equipment for the job. Avoid using damaged or defective tools. When working with electrical equipment, always disconnect the power before starting any work. When working at heights, use a ladder or scaffold that is in good condition. Wear appropriate personal protective equipment, such as safety glasses, gloves, and a hard hat. Follow all safety procedures and guidelines. After the cable installation is complete, it is important to test and certify the cables. Cable testing verifies that the cables meet the required performance specifications. Cable certification verifies that the cables have been installed according to industry standards. Cable testing and certification can help to identify and correct any problems with the cable installation. By following these safety procedures and guidelines, you can ensure a safe and successful communication cable installation. Remember to always prioritize safety and to consult with qualified professionals when needed. Proper planning, careful execution, and adherence to safety standards are essential for ensuring a reliable and long-lasting communication system.